And welcome to the Daily Space Weather, folks. We're going to get all deep into the weeds during the solar minimum and the, indeed, neo-renaissance. Welcome to the neo-renaissance. As astrophysics gets rewritten, it's for real. We're looking at the sun in 304 angstroms here. This is the last about 9.5 hours. Get the timestamps. There are the timestamps. 304 angstroms. We see a bunch of filaments there on the eastern limb. There is some activity rising, but there are no sunspots over there, and we'll show you that too in a moment, so stay tuned. Here's the 193 angstroms view also. There is a coronal hole rising there right near the solar equator, and we are getting the coronal hole wind stream. It took quite a while for the velocity to kick up, but it's looking like a characteristic solar wind stream out of that previous coronal hole that's now more like in a setting mode. This time we've brought up the 3-day real-time solar wind data to accentuate the fact that the coronal hole wind stream has been taking its time arriving, but we see the velocity kicking up just in the past 24 hours. So there's your characteristic coronal hole wind stream just hitting now. Current conditions are 4.22 protons per cubic centimeter as a density and speed 376 kilometers a second. Here's the 1-day data on ACE, and you see that characteristic density drop off at the same time as the speed increases. Standard fare for your coronal hole wind stream. Here's where planets are. Let me advance it 1 week. And there's where they'll be in 1 week as new moon approaches. Ever wonder what's going on above your head? Check out in-the-sky.org. Make yourself a sky map. Mercury just rose while the moon's on its way to set above mine. Now let's take a deep dive into cosmology. Z-fields run the universe, folks. Z-fields. Now, the Milky Way galaxy's core, Sagittarius A star, located about here, we are not on a perpendicular plane where we are in this. The sun is not on a perpendicular plane to Sagittarius A star. Sagittarius A star's disk is slanted about 40 degrees, which means its Z-fields pointed something like this. Okay, this is the way Sagittarius A star's Z-field would be oriented because of its major offset. Now, this blazar, which is the most luminous object ever imaged, this thing's Z-field, you're looking right down the Z-field. To make matters even more interesting, over here, this is the Cygnus arm right here. Deneb is located right there. That is the precessional North Pole at the other end of the precessional cycle of Earth's 24,000-year wobble. To make matters even weirder, on the other side of this, but in the same constellation, is another Z-field. Another Z-field generating object. Now this one we're not looking down the barrel of. Let me explain. Talking about Cygnus A. Now, if you're not aware of the importance of Cygnus A is the second most powerful radio source in the entire sky. Now here's a 5 gigahertz image of Cygnus A, but there's a lot of information about this as radio jets give us a very important fingerprint into cosmology. Let's go back to the drawing here. Things like clouds, planets, stars, and indeed galaxies form on these Z-field lines. This is how ionization pathways run the universe. So let me get rid of some of this stuff here. These things have a direct effect on your solar system. These things have a greater effect than the core of your own galaxy. If they didn't, the core of your own galaxy would return more radiation than these other sources. Now, there's a reason why we always follow these particular transients, and you can follow these on the Swift-Bat X-ray telescope. We'll leave links in the description to that also. And here's an example of how to look that up. Control F, you type in Cygnus space A, and there are the transients for Cygnus A, otherwise casually titled 3C405.0. And there are the transients from that. You can monitor that It's not a coincidence that the transients for this are directly proportional to the transients of Cygnus X3. I guess I'll show you that too. Here's Cygnus X3, otherwise known as Deneb, the local supermassive X-ray binary, and there's that signature. That is not a mystery, folks. Well, it is a mystery to some. And let's just leave it at that as we move on to talk about some more crazy stuff by the end of this video. Before we talk about the crazy stuff, we're going to archive 4 hours of data here on the magnetosphere movies. And we should see an increasing velocity here and a decreasing density. Anyway, this 4 hours of data, courtesy University of Michigan Geospace Model. And that's the density 4 hours worth. Here's the pressure, and we should see some variations in there. Fairly consistent with the solar wind. And we'll let that play through for your viewing pleasure. Show your friends, show your foes. Most people have no idea this is going on. And next we'll look at the geospace ground magnetic perturbations also, as this could play some sort of important role in somebody's data gathering process. So we try to be a resource for other channels that cover similar things. That's part of the reason why we show this every day. It's not just to make the videos longer and create a bunch of filler. Moving on. Are you familiar with the mission? If not, head to smashamash.com/forum/mission to realize that the mission is to assist, study, and report on the ongoing formation of a unified theory of physics, to raise the awareness of the general public of the relationship between space weather and Earth effects. Hey viewers, your weather and climate come from space. Weather and climate come from space. Welcome to space and the Neo-Renaissance. Also to connect and consult with media organizations to multiply our reach, which is the purpose of this YouTube channel, which is, shall we say, having some difficulty gaining traction. Also to demonstrate cutting-edge proof of concept solutions to problems. To publish scientific papers in a multidisciplinary manner, including but not limited to the sciences displayed on the screen. Also to assist mankind by advancing the study of predictive phenomena, and to not be ossified in our beliefs, and to treat those who are with love, respect, and inclusion to the scientific discussion, because that's how science works, folks. So please support us on Patreon if you agree with our mission, as it is our main source of income, not YouTube. So feel free to skip those ads, folks. Other ways to support the channel would be buying CBDs through our Spaced Out campaign, also linked below the video. We are also on other social media, such as Facebook, facebook.com/smashamash. Also on Gab, and we've recently changed the format, so look for more videos coming out. We're also on minds.com, minds.com/smashamash. The future of social media, it's open source, it won't censor you, it won't shadow ban you, and we're tanking over here. We need tokens, views, and new subscribers, as this is stagnating over here at Minds. Help us out, help out Bill Ottman. Make an account, come over here, send us some tokens. Pay homage to your favorite YouTube channels. Also check out original music, especially at soundclick.com/goldencatproductions. All kinds of fairly produced tracks there, more of the newer stuff. For instance, add Red Button to your collection for 99 cents. Yes, it is about the nuclear Red Button, but not Kim Jong-un's. Let's get back to space weather and realize that the X-ray flux is completely flatlined, as it's been since July 7th. KP index back down to 1. Electron flux not really dipping particularly. That's something to keep an eye on throughout the day. And when I say ion, pun intentional, as that coronal hole wind stream, we're looking for probably about my guess is 550 kilometers per second as the max for that coronal hole wind stream. There are the aurora forecasts, nothing to write home about there. And here's the last 6 hours of the F2 ionosphere movie. courtesy Australian government meteorology. Ionosphere is looking heavily discharged on the nighttime side, and a little on the anomalous side, folks. So there we've actually captured a bit of an anomaly there for once on the F2 layer. Something else to keep an eye on throughout the day. So fluctuating, always looking odd there around the South Atlantic anomaly anyway. GOES magnetometer is kind of all over the place. And again, there is some activity rising. We got a lot of stuff to cover, so let's continue on here. Now here's the Gong 2 data. And again, we've been saying this for days. There's some activity rising here. You see this suspended plasma. When the plasma is bunched up like this, it's because there's a powerful field holding it in place. However, there are no sunspots over there at stereo A. We'll even show you that as a value-added service. This data, 1 hour, 30 minutes old. And there's the last frame on that. Pardon me bearing down on the mouse. So here's the view from stereo A, and there are no sunspots out there, folks. This is a large active plage here. This one's gone all the way around the sun. We saw this about 2 weeks ago, and it's still about a week from facing the Earth. It will show up on the magnetometer soon. Anyway, there's the view from stereo A in 304 angstroms on the right and 195 angstroms on the left. Keep in mind the rotational difference here is because these are different time frames, as it's very difficult to get matching time-stamped images on this site. This is the integrated space weather analysis site. And it's an earthquake run down. Don't get run down in an earthquake by falling buildings. 4.8 in Nicaragua. That one taking place about 18 hours ago. Here's a 4.5 at Kazakhstan, 4.2 in Chile. Depth there 76 kilometers near the Blot Echo range, followed by a 4.6 at 122 kilometers. Again, we've been warning Western South America. If you're watching the video from there, please leave a comment. We've been warning Western South America for a solid week and a half about a larger quake at the surface, as they keep seeing deep quakes there on the west side of South America. 4.4 Costa Rica. That one is also at depth nearly 200 kilometers. Heads up there for a larger quake at the surface. 4.1 in Xizang. What the heck is Xizang? Is that a Chinese province? What is up with that? Tibet. Looks like it's on the Tibetan Plateau, folks. A Tibetan Plateau quake. That's an oddity. Put that one in your live journal. If you're viewing from the Tibetan Plateau, please leave a comment. If our videos are not shadow banned there, I don't know where they'd be shadow banned. And now I'm completely lost. And now I'm found. There's a 4.6 in China and a 4.9 in Japan. It's really a lull in earthquake activity, folks. The magnitude 6 and 7 earthquake drought continues. So if you're in an area prone to earthquakes, please have a plan. Go outside and look which building facades may fall down, as you're better off knowing that when you evacuate the building you're in, knowing which buildings could fall on your head. Even that is considered prepping, folks. And here's the pressure map, courtesy windy.com. We'll let this play about 24 hours. If you see anomalous low pressure systems and you've had deep earthquakes below your feet, be prepared for a larger quake at the surface. Anyway, there's about 24 hours of pressure. This is where things will be approximately tomorrow around this time. Today's volcano list so far includes Mount Aso, possible activity. Sanjiang Api, 10,000 foot ash plume there via some explosive activity. Tucono exploding, 6,000 foot plume there. Popocatépetl, 20,000 foot plume there, exploding. Sangay exploding. Revenador exploding. 19,000 foot and 17,000 foot ash plumes there, respectively. And Sabancaya down in Peru with a 24,000 foot ash plume. Please do not try to pole vault that explosion. It could be unhelpful. Let's go back to cosmology. On the tiny scale and on the big scale, via this phys.org article, researchers demonstrate three-dimensional quantum Hall effect for the first time. And yeah, just read the article. We'll leave links in the description. The Hall effect is super important, and it has to do with the way electrical current, magnetic fields, and things line up in 90-degree angles to each other. And let's explain that a little bit more in depth here. Now, we've been talking about the way the Hall effect is responsible for Earth's weather for ages on this channel. So here's a fairly good diagram of the field-aligned currents. So the currents that make the aurora borealis, in this case, as it's showing the northern hemisphere on the map, come in these two sheets. They're two opposite sheets that are going opposite directions. And this is a very good, actually, diagram here. And once this gets to the atmosphere, these Peterson currents get created as this thing tries to equalize. And that causes the Earth's atmosphere to act like a semiconductor. This is why you get these things that are called Hall currents. And those are those parallel lines that you see weather forming on, folks. That is the way it really works. And that is how things like the jet stream form. It's all based on this sort of stuff. It's not things like inertia and the Himalayan mountains acting like a bump on the planet. It's Earth's weather is caused by this system right here. Let's talk about cosmic rays. Cosmic rays create ionization pathways in the atmosphere. That is how they cause clouds to nucleate. Water is attracted to electrical current. I'm not going to make it any more complicated than to say that. When cosmic rays hit the atmosphere, they cause sudden cloud nucleation. Now, there are a bunch of different kinds of cosmic rays, so let's talk about what the term actually is. Now, it used to include things like gamma rays and X-rays, but cosmic rays are not a portion of the electromagnetic spectrum. Cosmic rays are actual physical particles. So the most common ones that are hitting the planet all the time are solar protons. There are also anomalous ones that we don't know what the point source is, and there are ones that come from outside the solar system but within the galaxy. Now, one of the very obvious cosmic ray sources is Deneb, otherwise known as Cygnus X3, and that's why we're doing a callback to this, because we'd like to tie all the information together for our viewers so they understand atmospheric physics. Anyway, these ionization pathways are the pathways on which clouds form. They're also the pathways on which hailstones form. When cosmic rays hit the atmosphere, they tend to turn into a shower, and they break into all kinds of other particles. They also create essentially atmospheric free radicals, and they cause all kinds of chemical reactions to happen in the atmosphere. We'll leave links to this article also. There are a bunch of links within the links. You may find it interesting reading. We hope you do. Let's go back to Earth. Now, we're looking at the view from 10 hectopascals, and we're looking right at Antarctica. I would note that this thing is completely off-center right now, and there are some disruptions happening right here toward the end of southern hemisphere winter. Kind of looking at the planet upside down here, and this is the very high pressure stuff going on in the very upper atmosphere. Northern hemisphere is looking a little bit more normal and a little bit centered on the geographic pole. The southern one totally not centered on the geographic pole at all. It's offset something like 400 miles. Now, this does change throughout the seasons, folks. It's nothing to really panic about. And we're going to show you the jet stream as we typically do. We just wanted to show you the way that rotation happens. That all has to do with Birkeland currents and Hall currents and Peterson currents, which we showed you on a previous slide. Here are the jet streams in the Western world, and they are all over the place. There's a large portion of it here, actually right off the coast of Virginia. That's moving the 100% opposite direction of normal, right there. And we see essentially convective forces are back to running the show here all over the place, as that is hardly a jet stream. Please leave a comment if you're a pilot and you know about this kind of stuff. And here's the southern jet stream. This is flight level 25,000. And actually massive convective forces down there as the southern jet stream goes from meridional to barely a jet stream. U.S. Doppler radar. is showing pretty devastating looking storms over Iowa. Shout out Aubrey. Have you gone into a concrete bunker today and put on a helmet? Here's the view from the NASA GOES water vapor map. And we see that water just poofing into existence. Must have been a ton of water evaporating on some sort of an ionization pathway. You hear that, folks? That's another call. That's what we call a callback. Here's the close-up view. Check it out. This thing is just a massive pressure gradient happening right there. As the air just dries out suddenly in one place, and water vapor shows up seemingly out of nowhere. The sky can suck the water right out of the ground, folks. Believe it or not. I've been studying this for decades. Trust me when I say it happens. As you can see it happening before your very eyes, we invite you to understand atmospheric physics with the real science and to avoid the non-science, which abounds the internet. Anyway, we use the water vapor map to see water vapor that's not even condensed onto a cloud, as that water vapor can't hide from this satellite. And let's move on. We're going to cover our favorite cosmic ray monitors, starting with Patati and Barentsburg. There's the cosmic ray scenario at Patati. There's Barentsburg. Recent uptick at Barentsburg. Next, we'll look at the Athens neutron monitor. Fairly standard range there in Greece. Next, we'll get a little closer to home. Mexico City. Fairly standard range there, nominal. And here's Moscow. Nothing to write home about there either. And while there are a ton of other cosmic ray monitors that we could look at, folks, here's Oulu, Finland. Standard nominal range there. Here's DOMC Antarctica. Nothing particularly exciting there. And there's DOMB Antarctica. Looks like some data loss. And we've brought it back to the sun here on the colored magnetogram to show you that there are no exciting fields happening and solar activity is still looking weak. 10.7 centimeter radio flux is still at 68, folks, which we like a little better than 67. And finally, here's the 171 angstroms view, my personal favorite. Thanks for tuning in, everybody. We are out of here. There's about 9 hours of solar activity here, 9.5 hours. Thanks for tuning in. Please like and subscribe if you haven't done so yet. Help support the channel via the links below the video. And we'll be back again in a moment to do another video. So, thanks again, folks. Have a delightful day, and remember, since it'll never be now again, may the solar wind be at your back and the atherosclerosis absent from your